In this video, I will be tuning our BioContinuum energy filter and collecting the K3 camera gain on our Krios equipped with a Cold-FEG. Want to navigate to a broken square? I'll choose this one here, go to marker. Take search to verify. Going to change to the record mag. Right, I'm at 130kx, so I'm going to adjust that to 80. Oops, wrong direction. 1 angstrom per pixel, close to 81 kx. Okay. Use continuous update to pull those settings into record because that's what I'll be using. I need to go to the microscope PC and find apertures and put in the 150 micron C2 aperture. Wait for that to insert. Alright, now I'll use illuminated area or the intensity knob to adjust the beam. I want to have an illuminated area of 1.5 microns. So I'm at 1.8, 1.78 right now. Okay, that's close enough. And what I can do is lower the screen and let's see what the screen current is. So here we go. My screen current reads 2.13, 2.15 nanoamps, and I want a value that's greater than 3 nanoamps. And what I can do is lower the spot. The spot's the C1 lens, and so I can do that with the hand panel. Oops. Or the serial MPC. Let's reconnect. Okay, 2.3, serial MPC, I'll do lower the spot. I can see screen current here on serial MPC as well. So I'm at 3.8, so that's good. Now I will begin tuning the GIF. So I want to tune the GIF before collecting a gain. And so to do this, what I will do is let's verify that an image is being produced. So I'll raise the screen. On digital micrograph, I'm checking to make sure that the temperature is correct. So always make sure the temperature is -20 before beginning. And I see tune GIF is yellow, it needs a retuning. But I want to make sure the slit is in the correct position. And so the first thing I will do is click center ZLP. The slit's removed for center ZLP and then reinserted and moved back and forth. There we go. Again, off, but it was good. It wasn't adjusted. And now what I can do is go to camera, prepare dark reference. I should manually prepare a dark reference before any of these procedures. It's just good practice. All right. Now I'll click Tune GIF. And let the automated procedure complete. First thing it does is center ZLP, which we just did, but it's best to do it manually first, and then it's going to do isochromaticity. This is pretty bad, look like a rainbow. You want it more of this pukey color. So it'll go again. Good, passed that time. This is a BioContinuum, so it's a very fast filter. Now the mask for correction. Very nice. Great energy filter. So see what the log says. This was where we started, right here. Looks good. Okay. Now that the energy filter is tuned, I can proceed with collecting a gain. I'm going to again prepare a dark reference. Camera, prepare gain reference. I need around 1,500 counts. It's at 800 now, so I need about double. In a situation where I need to double, the first thing I would do is lower the spot. But since I can't do that, I'm going to lower the. I'm going to use the intensity knob or illuminated area to shrink the beam down to 1 micron. So what I'll do is in ZL/EM, double click the bar so that we can see it, both of them, drag it to the side, and I'll use illuminated area, and I'm going to go down to 1 micron, or stop before then if I get in the green. Yeah, so I want about 1,500. Let's get close. So there we go. 1.09, 1.07, looks great. What I will do now is lower the screen, move to the microscope PC, and just verify that the beam edge wasn't getting clipped. This looks good. Or the beam edge wasn't in view of the GIF entrance aperture. That looks good, so I'm going to click done. Okay, so the linear gain is complete. Now I'm going to do counting. So before beginning the counting gain, I'm going to insert the screen and change the spot size to 4. So I'll use the virtual hand panels this time around. And if we look in this bottom left, I can see spot size plus is bound to R3. So I will click R3 a couple times. So that's spot size 2, spot size 3, spot size 4. Okay, that brings me to about 0.5 nanoamps of screen current. I could center the beam here as well, but I'll just leave it for now. So back to the Gatan PC, I'll click OK. It's going to calculate the dark, and then I'll lift the screen once the view begins. Okay, I want to get to around 20. So lift the screen. I'm at 35, so easiest thing to do would be spread the beam. So I can use illuminated area in Cryo-EM. And so I'll do that right here. I'm at 1.06 microns. So let's go up to 0.25 and see. Still a little high. Turns out it's 0.5 that I want to go for. Back to 0.5. And then here we go. Yep, 19. So if it's around 20, so I could go on the high side, but we collect between 15 and 20 electrons per pixel per second. So I like to have my gain around this number, you know, on the lower side of 20. So I will click done. And now that will collect. All right, gain collection is complete. Now we should test the gain, and the way to do that is by autocorrelating an image over vacuum. We need to take a full exposure, and what I mean by that is a properly dosed image at the proper dose rate, something on the order of 50 to 60 electrons per square angstrom total dose, and between 15 and 20 electrons per pixel per second. Since we have a 1 angstrom pixel, roughly, the math's easy. So we can just take the dose rate, and that's in electrons per pixel per second, and then that would be the same electrons per square angstrom per second, and then we just need to take an exposure that's long enough for 50 to 60. So with this microscope, since we just did the counting gain and it was about 1920 electrons per pixel per second, a 3-second or 3.22 second exposure would be perfect. So I will first click view, and we can just verify the dose rate. So we'll see this in the bottom where my mouse is. Okay, there we go. So adjust the view exposure to 0.1. It is sensitive. The dose readout is sensitive to how long those slices are. So I would recommend 0.1 as the minimum when using view. So that gives us 19.4, so basically 20. So let's just do a 3-second exposure and click capture. Now you can see at the bottom that we have a total dose of 49.6, so basically 50. So maybe I could have used 3.1, but it doesn't matter. And so now I'll go to process menu, autocorrelation, and I'm going to look at this image, and you can see that there's nothing in there. And what I mean by nothing in there is there isn't any banding. I mean, it looks like there's some like light banding, but I don't think that's real. It might just be my display. We can see the point in the middle. That's always there. But this is, I think this is just compression artifacts. So this is not what I would expect for a bad autocorrelation. So this means things are looking good. Let me show you an example of bad autocorrelation. And so to do that, what I'm going to do is underdose the camera. And so if we remember, we'll get about half the dose rate with every change in spot size. So what I'm going to do is lower the screen, increase the spot size to 5, raise the screen, and then take that same 3-second exposure. And so I'll have about half the correct exposure. Let's see if this will work. Okay, so about 10 autocorrelation. Yeah, and so now you see some banding. So this is one example. So this is because it was an underdosed image. So remember, we need to create a good exposure image. And so this may be a reason that you would check this at the end before your collection starts, once you have your record beam set up. So what I'm going to do now is offset the beam and show you what it looks like when there is something like fringing. So we have fringe-free illumination on these microscopes, so we don't have significant fringing, but if you have a microscope that does have fringes that come off of the C2 aperture, it's good to check for this. So let me show you an example. And so what I'll do is I've lowered the screen. I'm going to move over to the microscope PC. We can see that there. And so what I'll use is I'll use multifunction X to move the beam. I'm going to change this to 50. And you can see it's coming offset. So let's just do that. Once it's in the field of view of the camera, looks good. I will now go back to Serial-EM. Going to raise the screen. Now DM. I'm going to, I also need to change the spot size back. Did I do that? Nope. So let me do lower screen. So lower the screen and spot down. Okay. Now I can raise the screen back to digital micrograph, and now I'm going to take again that 3-second exposure. Yep, I see the beam edge in view. And I'll go process, autocorrelation, and here's another example of a bad autocorrelation. And so if I put these two next to each other, there are these three next to each other, this is what we have. Oh, and then I don't have the good one, but it's fine. Okay, so let's close these. And we can get started with additional tuning on the microscope. Thank you for watching our video. If you found it informative, please like and subscribe. Comment below with any requests for videos and any questions you have, and we'll be happy to answer them. If you're interested in attending one of our in-person or online workshops, please visit our website at pncc.labworks.org for more information.